Pahud there. Hello everyone, how is it going? Welcome back to my channel. My name is Pahud. Last week I just made a vlog talking about how to create your AWS CDK pull request. It was in Mandarin though, but we already have some very active developers, especially in Taiwan, Hong Kong, and mainland China, that have started their first AWS CDK pull request. And some of them are even in the review process now. This is really amazing and exciting to me. So today I'm gonna create this content in English. Hopefully you guys can learn from this video and successfully create your first AWS CDK pull request. Okay, so let's get it started. Let's go to the AWS CDK GitHub repository and scroll down to see the CONTRIBUTING.md. Quite a lot of content talking about how to make pull requests and all the required tools and how the workflows look like. It's pretty challenging, especially when you need to get your local dependency ready. For example, you not only need the Node.js Young, but also Java, OpenJDK, Apache Maven, .NET Core, SDK, Python, Ruby, Docker, etc. But most of the time, you're just a TypeScript programmer or Python programmer. You probably do not want to install so many toolchains, so many dependencies in your local laptop. So later, I'm gonna show you how to build your local environment with Docker without installing the, for example, Java, Apache Maven, or .NET Core SDK. Let's go back to the AWS CDK repository. On the top right, there's a fork button. Click the fork button to fork the upstream repository to your remote personal space. So, for example, in this case, I have already forked the AWS CDK repository to my personal space, which is Pahud AWS CDK. Jump into your personal repository. Click the code button, copy the repository URI, and clone this repository to your local environment. So now I'm opening my local terminal like this. Git clone this repository from my remote space to my local environment. 1 or 2 minutes, depends on your network speed. Okay, as soon as your local repository is ready, let's just jump into the repository and open the built-in terminal from VS Code. Okay, so now we are in the local repository, the master branch, right? And what I'm gonna do is to run the yarn install to install all the required tools and modules for this environment. In case you do not have Yarn installed in your local environment, you can go to the Yarn homepage and see how to install it in your laptop or development environment. For example, in this case, for Mac aws-ecs, install it with brew install or through the Mac ports, or simply install it with the provided script like this. And after the installation, run the Yarn version to check if it is working in your local environment. Okay, so first we're gonna run the yarn install all the required packages for your local environment, and this might take 1 or 2 minutes. Okay, so now we have installed the required packages with our initial yarn install, right? And now we're gonna run the yarn build. Just run the yarn build to start the building, but personally I prefer to run it with Docker. So this will bring up a JSII superchain Docker image and create a container with that image. Everything required would be already bundled in that image. And there's a skip test, which means I just want to build it. Please don't run the tests. All we need now is to generate the L1 constructs so we can start building the L2. If you are ready, just hit the Docker run. It could take up to 30 or 40 minutes, depends on your CPU performance, so just be patient. So feel free to grab a coffee and come back later. Okay, so after 30 or 40 minutes, yarn build will be completed. Under the hood, the yarn build will generate all the L1 construct libraries, the basic constructs for L2 constructs. Most of the time, we create pull requests to update an existing construct or create a new L2 construct, all based on L1 constructs. So you have to do it once for the first time. If we go to the left Explorer and open the packages, open the @CDK, there are a lot of L2 constructs. For example, if we jump into the, for example, AWS ECS, click lib and open the index.ts, scroll down, and there is a ECS.generated, which contains all the L1 constructs for the Amazon ECS construct library. This file is generated from the AWS CloudFormation resource specification, and there are quite a lot of interfaces, functions, and classes starting with the CFN prefix. Classes with the CFN prefix indicates they are L1 constructs, and we need to generate all the L1 before we can start building L2 on top of them. That is why we have to run the initial young build in the very beginning, and most of the time we just need to run it once. So before we start creating a new issue, it's very important to see if there is any existing GitHub issues or pull requests available in the repository. Just jump into the search box and search any keyword. For example, ECS capacity provider. There is AWS ECS capacity provider resource available in the changelog from the CFN spec, which means that this resource is already available as L1 construct. We just click the issues, ECS support capacity provider. Actually, this issue is created by myself, but it doesn't matter. Let's see what this issue looks like. If there's someone already raised the issue, we just follow this issue and add more comments. Otherwise, we can create a new issue. It's also very important to see if there's any pull requests available. If someone has been already working on this issue with a new PR or PR draft, then we do not have to duplicate the issue by creating another one. So in this case, this icon indicates it's a pull request, capacity provider pull request by myself, which means there's already a pull request. I will talk about the pull request later. At this moment, the most important is to make sure there is no existing pull request before we create a new one. Let's go back to the VS Code. At this moment, we only have the master branch from our remote repository. You can simply run the git branch to see if there's any other branches. Because I've been working on many different pull requests, in this case I have many different local branches. But if you are first time doing this, you will only have the master branch. So what I'm gonna do is create a new branch from the master branch. In this case, I'm gonna run the git checkout with the -b and the new branch name, which means that I'm gonna create a ECS capacity provider L2 branch from the master branch. I have been already working on this pull request, so I already have the local branch. But in your case, you can create your new branch with this command. For me, I just need to switch to that local branch without the -b. So git checkout. Okay, now I'm in the ECS capacity provider L2 branch. Because the L1 constructs we have built are not managed in the GitHub repository. So even we switch to a new branch, we still have the L1 constructs we previously created from the young build. So now I'm gonna create a pull request for the Amazon ECS. Jump to the packages at AWS CDK and scroll down to the construct library. For example, AWS ECS. And in AWS ECS, we have subdirectories like lib and test. Lib is the most important because all the libraries are available in this directory. And test is the directory for all the unit tests and the integration tests. Files starting with the test are the unit tests. And files starting with integ are the integration tests. We'll talk about the tests later. But for now, we just need to figure out the difference between lib and test. To get it started, create a new integration testing and try to build with my desired pattern or classes. For example, I was working on the ECS capacity provider. So I have an integration capacity-provider.ts TypeScript file like this. It's AWS CDK in TypeScript, just like the common CDK apps we have been already very familiar with. Import all the required modules, for example, ECS and CDK core. And for the ECS library, we will need to import from our parent lib directory rather than import from the AWS CDK or AWS ECS. because we're already in the lib directory. So we just import from the parent lib directory. And just like all the CDK apps, we create the app first and create a stack, create a VPC, create a cluster. And the most important is the following statement, because in fact they are not available in the CDK construct library, but we are going to build it. So we can try to write our own patterns like this. For example, the cluster is already layered, and we are going to extend a new method at capacity provider, which was not previously available, but we are going to create this method. So if the method is not available, for example, like this, then your VS Code will indicate that there's an error because the method is not available, right? But when we create that method, it will be available with no error, like this. So how do we extend the existing class with new method or create a new class? Go to the lib directory cluster.ts and scroll down to the cluster class and create a public function add capacity provider like this, and implement the logic for this method, including the properties we are going to pass to the method and what it's going to return. We need to define the interface. In this case, capacity provider asks for the required properties and the capacity provider as the return object. So in this case, I will need to create a new file, for example, capacity-provider.ts under the lib directory, to define all the new interfaces and all the new classes for this PR. So this is the capacity-provider.ts under the lib directory, which is part of my pull request. I need to define all the required interface and the construct classes. For example, in this case, I've created a capacity provider classes, which extends the CDK resource and implement the capacity provider interface I've already defined in the same TypeScript. So this file is where you create all the required constructs and interfaces and functions as well. And when you are developing your CDK constructs, create a second terminal like this and go to the same directory. For example, in my case, I'm going to the packages at AWS CDK and the AWS ECS and run the npm run watch. This command will keep watching your TypeScript to see if there's any modification, any update on the TypeScript, or compile it into the JavaScript. Make sure there's always 0 errors in this terminal, otherwise it will not build successfully. So make sure this terminal always return 0 errors. I'll show you how it works in action. For example, I'm gonna create a new method like this. Okay, in this case, 1 error. This method is not available. So when we create this method, and the error message will be gone, and the npm watch will return 0 errors. So always open your npm run watch terminal like this and ensure there's 0 error. If there's any error, try to fix it as early as possible. Okay, if everything is good with 0 error and your integration testing is looking great like this, start deploy our integration tests into our real AWS account. Okay, in AWS ECS directory, simply run the CDK app test capacity provider.js diff. So this will run the CDK diff against your integration testing. If everything is looking good, start the CDK deploy like this. And yes, now it's gonna deploy the integration testing into my AWS account. So it's very important to working backwards from a new integration testing to simulate what user experience, what patterns you're gonna create, and always make sure the new pattern or new library is always working in real AWS account, real AWS environment. Okay, so make sure it successfully deploys in your environment, and then open the browser to confirm all the details and ensure all the resources have been already created. Okay, in my case, if we go to the CloudFormation console, there will be a new integration testing stack already completed, and all the resources in this stack have been created by the CloudFormation. Go to the Amazon ECS console, cluster is being created. And the most important of all is the capacity providers are all created as expected, and all the instances from the capacity providers are up and running. Everything is working as expected. Then I have confidence the integration testing should be working with my new libraries. If everything is good, we will need to create the snapshot of the integration testing. So what is the snapshot? The snapshot is the expected.json file, which is generated and will be submitted along with your pull request for the CI system to make sure that your integration testing is gonna be working as expected. So now I'm gonna create the expected.json file like this. Young integ and point to your integration testing JavaScript. Make sure to remove the preceding test and hit enter. We'll deploy the integration testing again to your environment. Okay, now the young tag is deployed and the expected.json file is generated like this. The cleanup is gonna destroy the deployment to make sure the integration testing environment is cleaned up. So how can we ensure that the expected.json is valid? We'll need to run the command young test, which will validate all the integration testings as well as the unit tests. It validates all the existing unit tests and integration testing, and all the existing unit tests should be working without any errors. Our integration testing is expected to be here. It's verified as expected. Before we commit the pull request, we have to run the young test to make sure our integration testing and all existing tests are all verified. And of course, it's also very important to write your own unit tests, but I'm not gonna dive into the unit tests in this episode. Let's jump into the existing one. For example, test ECS cluster.ts, which is the unit tests for the ECS cluster. Quite a lot of unit tests for different features here, and the expect method can do the resource assertion to make sure it works as expected. Let's assume the unit tests and integration tests are all doing great. Before we move to the next step, we need to run the young build. Build the current CDK construct, in this case, Amazon ECS from my local environment, to make sure that the construct is doing great without any error. And it will also trigger the AWS lint to make sure your coding is compliant with the coding style defined by the CDK team. So in this case, we need to make sure there's no error, zero error. And if there's any warning, it doesn't matter. We just make sure there's no error. Always fix errors when, if available, from local. Otherwise, we are not gonna pass the CI testing from the tool build. If everything is good in this stage, then we can start commit and push our code to the remote repository. Git add and commit ECS capacity provider, and then git push to your remote fork repository. There will be a pull request dialog box in the AWS CDK upstream repository. We just open the browser to the upstream, and you will see there's a yellow dialog box which is ready to create a pull request, and simply click the create a pull request, and you will be directed to this pull request page where you need to write the title, the description, and everything required for the pull request. So this pull request title indicates that it's a new feature or feature update for the Amazon ECS construct library related to the auto-scaling group capacity provider, and you are required to note the issue number in the PR description like this. For example, closes 4571. The pull request will be linked to the issue. After you create your pull request, you still can continue to git commit and git push to the same repository. The reviewer of this pull request will be assigned very soon. So if you are ready, you can tag your reviewer and ask for the initial run for the review. If you are not ready, you can always convert to the draft state by click the convert to draft link here, which indicates that you are not ready, you are still working on it. Please do not review at this moment. There is a co-build CI system which will be triggered every time you push your commit to the repository, and you need to make sure result is always succeeded. Otherwise, you will need to jump into the CI build log to see the error message, and always make sure all the checks passed like this. I hope you find it very useful to help you create your first pull request. And to be honest, making contribution to AWS CDK is one of the most exciting things I've ever had during the past few months. Today we have over 400 CDK contributors, and I'm very happy I'm part of them. Making contributions to AWS CDK is a really great experience. You don't have to stay at home. You can go to anywhere you like, as long as you have internet, and start building your pull requests from your local laptop and keep iterating with your pull requests with your reviewers. And as soon as it gets merged into the master branch, you can expect the next release within a week. And after that, everyone in this world can get benefit from your contribution. That is really amazing experience. Okay, if you like this episode, please hit like and subscribe my channel if you haven't. And feel free to share on Twitter or any other social networks so that more people can watch this video to make different contributions to AWS CDK. Okay, see you next time. Bye.